Alright, hello, welcome back. Today we're going to be using our calculator quite a bit to determine lines of best fit, determine regression models, and visually see what types of parent functions best fit the data that has been given. So we're going to go ahead and start with question number 1. In your calculator, you're going to want to follow these keystrokes so that you're familiar with them. In some cases, you may already be familiar with what to do, but let's go ahead and go through it anyway. When you're given data, such as the data that's in this table, there's a way that you can input it into your calculator and have the calculator graph it. That data can be inputted into the stat key. Because data is statistics, that's why it's under the stat key. Now you'll have 3 different categories that you can work through. We'll be working primarily in the edit and the calc menus. The tests are for standard deviation, mean, median, mode, variance, all of those things. Alright, so if you look here, we're going to edit our list of data. Now, for time's sake, I've gone ahead and entered mine in, but you're going to want to do that right now. The first thing you're going to want to do is you're going to want to type in your X values into list 1, your Y values into list 2. Now the first thing we want to do here is we want to look at what the data looks like on a graph. The easiest way for us to do that is to go into the Y equals menu. When we go into the Y equals menu, you notice these plots above the Y's, and you want to just go up to plot number 1. Once you hit enter, that will turn on plot number 1. Now if we want to edit what happens in plot number 1, we just do second Y equals, and that gets us that stat plot. But I'm happy with what is in there now, so I'm going to go ahead and just graph it. So as I graph it, I notice that none of it shows up on the graph. Okay? And that's because the Y values are all above the viewing window. There are 2 ways that we can fix this situation. The first, on question number 1, the first way we're going to fix this situation is by using a specific zoom. On question number 2, we'll go ahead and readjust the window size so you can see both ways and decide which way works better for you. So into your zoom, we're going to go ahead and go to the bottom. Now I'm going to push the up arrow, and that'll take me back down to the bottom. I'm looking for, there it is, zoom stat. What this will do is it'll resize the window for the stat plot that has been graphed. Now you can clearly see what parent function this is modeled, and that would be linear. So we'll go back to question number 1 and we'll fill that in. In question number 2, we go back to our stat menu, go back to our edit screen, and you fill in your second group of lists. Now the easiest way to do this is just to overwrite. So whatever was written here before, just put your cursor again and overwrite it. If you go up to the top where L1 is highlighted and hit the clear button, it will clear the entire list. Please do not hit the delete key, as this will actually delete the list. You'll have to go in and reset that if that's the problem. So if you notice that you are missing a list for some reason, then you just go to Stat, number 5, Setup Editor, hit Enter, and it will bring all of your lists back into view again. Alright, now with all of your values inputted properly, we're going to go ahead and go back to the graph. You'll notice if I go back to the Y equals menu, the plot is still turned on. It will remain turned on until you turn it off again in the future when we're finished with this. Now I'm going to graph it using the same window as I had before, and you'll notice that that window is not sufficient to see all of the points. Now I told you we were going to do the other method for resizing our calculator screen, and this time instead of going to the zoom, we're going to go to the window screen. Now we're going to look at the smallest value of x and the largest value of x to determine what the minimum and the maximum value should be. I'm going to go ahead and put 0 here because that's smaller than 4. I'm going to go ahead and put 10 here because that's larger than 8. The scale is the number by which it's counting, so I'm okay because the numbers are small enough that are counting by ones. I'm going to go ahead and change this one. The smallest value I want to use here is going to be 0, and the largest value I want to use here is going to be 50. That way I've guaranteed that I can fit everything in. Right? And now I'm going to graph it. Okay? So from this viewing window, it doesn't quite look linear. And you can see that there's a bit of a curve to it. So we are going to determine that this is a quadratic parent function. Now there are some other things we can do here to prove that that is, but for right now what we're going to do is we're going to just look at the graph. Later on we'll look at regression lines. In question number 3, we are going to utilize the multiple choice answers to help us determine what's going on. So we're asked to determine which equation fits the table that is given. So we're going to use each of the functions to figure out what tables they have and match it to this table that's given. Now for time, I've gone ahead and put in all 4 of my functions, but you can just type them in one at a time. We'll go through each one of the specifics so you know how to get your calculator screen to look like this if you're unfamiliar with how this works. The first thing I want to address is the fact that plot 1 is still turned on. So I'm going to go up, I'm going to hit enter, and I'm going to turn that off. Now that I've done that, now I want to address number 2. The second item I need to address is how to get this particular symbol on your calculator screen. You'll find that a majority of things related to symbols will be underneath the math key, okay? And once you go into the math key, you'll notice that option number 4 is a cubic root. Going back to the y equals menu, just type in x. Now what I'm going to do is I'm going to go to my table and I'm going to match my table values. I'm at 11, I need to be at 0.5. So I'm going to go down here to 0.5. Oh, I don't have a 0.5. So now what I've got to do is I've got to go in and change that to 0.5s. Okay? So the easiest way for me to do that is inside of this menu called Table Set. Second, Table Set. I'm starting at 0, and this delta table, the triangle table, actually means the change in the table. And I want the change in the table to be on 0.5 intervals. You can change that to anything you want, and now you have the numbers between the numbers that you don't normally see. Alright, so I'm going to 1/2, and I notice that I'm not even matching. 1, 1, not matching. Okay? So I can eliminate this answer choice because the table doesn't match. Going into y equals, you can turn off a particular y even if you don't want to delete it by simply hovering your cursor over the equal sign and hitting enter. Now I'm going to highlight this one. The third thing I want to point out for this particular exercise is how to create that fraction. You're going to have this alpha window, alpha, and you see these soft keys up here, F1, F2, F3, F4, F5 will be in the F1 menu here. Notice it says numerator over denominator, and that's how you get your fraction. Okay, so you can do a lot of work here with fractions, mixed numbers, changing your fractions to decimals, so on and so forth. Okay, so I'm going to go back to my equals screen, and here we go. Going to my table, you'll notice that I have 0.5, 0.25 not matching, so I'm going to eliminate this one. Okay, so on and so forth all the way through. So you're just using test-taking strategies here to determine what your correct answer is going to be. As you can see from this, neither A through D matches any of this material. That's clearly an error, but we will correct that. And the most important part about this is that you're understanding the process involved in this rather than the actual outcome. So that was an error analysis piece that we found out the error for. All right, moving down to question number 4. All right, go ahead and pause the video now. Give yourself some time to fill in these ordered pairs onto your graph. We're going to utilize them to help us determine lines of best fit and regression models and predict what a person would be making based on years of experience. Okay, so the first thing we want to do here is we want to take a look at the data inside of the calculator. So again, go to your stat, go to your edit, and type in your data. Be careful to make sure it all lines up. It doesn't have to be rearranged, just type it in exactly the way you see it. Once your data has been typed into the calculator, you're going to want to go back to your stat menu, and this time we're going to utilize that calculator function. Over 1 gives us all of this information. The most important thing that we want to look at are these regression lines. 4 starts with your regression. Linear regression, quadratic regression, cubic regression, quartic, and there's some more down here. The ones we're really going to focus on today are 4, 5, and maybe a little bit of 6. But basically we're looking for linear regression versus quadratic regression. Now I'm looking at this data, and although it is not in a straight line, it is going to follow basically a linear relationship, because it looks like my lines are going up at a steady pace instead of going up at a more generally increasing rate. So that's why I'm going to choose linear regression at first over quadratic. So when I put that in there, it's going to give me a list of options. I remembered that I put my X list into list 1 and list 2. This would change obviously if you had more data in the calculator. This one is not important, and this would be if we wanted to actually get the equation into y equals, and that's something I want to do later, so I'm going to go ahead and do that right now. Y equals is a variable, so I need to go to the vars key. When I go to the vars key, I have some vars that come up here. The one that I really want to put in is this y variable. Okay, it's a function. This is for the other options, but we're not dealing with those right now, and we're going to go ahead and put that into y1. So what that's automatically going to do is that's going to take whatever regression this comes up with, and it's going to type it directly into y1. It'll overwrite whatever's there. So see that I have something already in my y1 from the previous problems. It's just going to type it in right over the top of it. Alright, and then I'm going to hit enter one more time to calculate that thing. Now that it calculates it, you get this. And you can see inside of my window that it actually just overwrit what was already there. Okay? Alright, so let's take a look at what this means. Y equals ax plus b is just mx plus b, but that's an a instead of an m. So the slope of your line is 1.23 approximately, and the y-intercept is 5.57 approximately. So we're writing a function that best models this data. That is what is known as a line of best fit. Okay? So we're going to go ahead and write that in there. Y equals 1.234. Let's go ahead and get into the habit of writing it to 3 decimal places. That's something that'll come in handy later. Plus 5.574. 574, excuse me. So there's our line of best fit. Alright? Let's go ahead and attempt to put that appropriately on this line. And then we'll show exactly where it should be. Alright, so I'm going to start at 5.57. which is going to be about right there. I'm going to show a slope of approximately or a little bit more than 1. And I'm going to estimate my line of best fit to be about that. Now what we're going to do is we're going to determine or back that up in the calculator with our window. So go ahead and change your window. Now that the graph is given, this is nice because we're just going to type this in exactly the way we see it. Y minimums and X minimums are both 0. The X maximum is going to be 13. And my Y maximum is going to be 22. Now I'm going to graph that thing. Sorry, not going to graph that thing because I got some issues going on inside my calculator. The first thing we've got to do is I'm going to turn off everything that's in there. You shouldn't have anything in if you typed yours in into Y1 earlier. And the second thing I'm going to do is I'm going to turn on plot 1. Remember, we have to do that so we can see the data. The reason I'm going to do that is because it's going to make it model exactly what you see here. Okay? Now go to your graph. And you'll notice that our line of best fit that we approximated inside of our graph lines up pretty closely what's actually inside the calculator. So we're using this regression model to help us out here, and that's what's going on in this particular case. Okay? All right, the last thing we need to do is we need to predict how much a person who has 7 years of experience is going to be making. Now the way we're going to do this is we're going to go ahead and use a line here, and we're going to watch it intersect our line of best fit. It looks like that person should be making $14. So we're predicting here. We're not actually finding the actual amount that there's going to be. Now we know that 7 years is on the x-axis, so I can come back over here to my table and I can verify if my prediction was correct, or at least close. So I'm looking for a person. I'm looking for a person who has 7 years of experience and they're making about $14.21. So my prediction was pretty close based on my line of best fit. Question number 5. All right, in question number 5, we've got some more data that we want to represent here. And now I'm going to introduce a new tool into our data collecting arsenal. And the place we're going to find that is in the catalog. So go ahead and hit second 0, and that's going to open up our catalog. Okay? I'm going to go ahead and go to the D section of the catalog by hitting, see how the alpha key is already locked, hitting X to the -1, which is also D. Okay, now I'm going to go ahead and scroll down until I find something called diagnostic. Diagnostics are tools that you can use to determine whether or not a line of regression is perfect, close, or way off. Okay? It's a toggle switch. One is off, the other is on. We want this to be toggled on. So highlight diagnostic on, hit enter one more time. The calculator's told us it's turned on. Now this turns on two different things in the calculator's algorithm. It's a variance and a standard deviation number. Now the closer these are to 1, the more perfect the line of best fit is. That's what we're going to use here if we're in question about which line of best fit is going to actually represent this data better. Okay? So into the stat we go, edit, set up your lists. Okay? Once you set up your lists, go to stat, calculate, and let's start with linear and let's see what we come up with. Because the important thing to understand about this is that the calculator is always going to give you an answer. Some answers are just better than others. Okay, so now you notice that r squared and r both show up on my list. And both of those numbers are pretty far away from 1. So even though this could be represented as a linear function, both of these numbers say that it's very unlikely that it's going to be the case. Okay? So I'm going to go ahead and store 0.4 in my mind for just a second, and as long as the next model I use is bigger, closer than 0.4, I feel like that's a better one. So I'm going to go back to stat, calculate, and this time instead of using linear regression, I'm going with quadratic regression. Number 5 goes down here, and let's go ahead and take a look at it. Alright, So now notice sorry about that. I had a wrong number in there. Now notice that our r squared is at 0.99%. So that means, or 0.99, that means that there's a 99% likelihood or probability that the quadratic model fits this set of data. So we're going to go ahead and say that that is what it is. Quadratic. Alright, the regression function that we're going to use is this one. We're just going to use substitution to substitute that in. Alright, so we get y equals 15.625 x squared plus 93.375 x minus 0.5. So that's going to be our regression model. And then according to our model, how high does the golf ball get? Well, okay, we're going to go ahead and graph that. So the way that we do that is by taking our stat again, calculating it, back down to number 5. Alright, we're going to go in here and we're going to store the regression equation as a variable in our y equals vars menu, and number 1, and there we go. And getting that in there, now it's set. Notice it shows up. You can go in and confirm it yourself. You can see that there. Alright, we're going to go ahead and change the window so that we can see what's actually happening here. It looks like 145 is going to be pretty close to the top. So I'm going to go ahead and look at somewhere around there for my window. I'm going to go ahead and move this up to 160 just to be on the safe side. I want this to happen only once. Oh, there it is. It shows up on there for sure. Alright, we'll get into this a little bit more when we get into quadratics, but we can determine what the maximum is going to be by going into your calculate screen, second, trace, and we can go to number 4, maximum. Now, the way you have to do this is you have to move the cursor on either side of where you think the maximum is. So I'm going to bring the cursor back to the left, and I'm going to show that, okay, I think that I'm to the left of the top. And I am. I'm going to go back again to the right. And then notice I've moved my cursor beyond where I think the top is, over to here to the right of it. Hit enter. That's what these bounds say, right bound, left bound, etc., etc. The guess is unnecessary in this case because it's so close in there. And according to this model, it says that the graph's maximum, now remember this is not the data's maximum, this is the line of best fit's maximum, is 139. So that's why there's a disconnect here. Remember, we're only at 99% accuracy, not 100% accuracy. So that's why that's the case, okay? The line of best fit is just the calculator's best guess based on the data that's given. Now the thing about this is in real life, you're not going to get perfect relationships, and that's why we have an issue like that, okay? All right, question number 6. All right. Question number 6, where Alex is driving in his car. Notice we've been given some time and then some fuel that's remaining. We're going to look for a line of best fit, and we need to find some clues in here that are going to help us determine whether we're using linear or quadratic. And right here, this clue right here is the key that tells me that we're dealing with linear here. The same mean speed. Mean is average, average is slope, so we're looking at a slope here. We're looking at a rate of change which is consistent, all right? So we're going to go straight to the linear. So go to your stat, type in your data into your table, and double check and make sure I'm not putting in the wrong values like before, all right? And now we're going to go to our stat menu again, go to our calculate screen, and straight to linear regression. Number 4. I'm going to fill in all of this information. I'm going to stop at store regression equation, go to my variables, go to my y variables, type in my function, and I want it in y1. Calculating this, my line of best fit is negative 8.24 x plus 49.96. And he's got a pretty big tank. You'll notice that this was actually starting at 50, so 49.96. Notice that my diagnostic tools tell me that it's not going to be a perfect line of best fit, but it's going to be a pretty good estimate because it's at 99% accuracy. Now what I'm going to do is I'm going to go back to my table again and figure out what my value will be at 3.5 hours. Now luckily for us, we had changed the table set from before, but it looks like we're at 0.25, so just for practice sake, I want to change it one more time. So think carefully about where we go to set our table. So we're going to go second window, that's our table set, and right there I want that delta change to be now 0.25 instead of 0.5. Now remember, that was unnecessary because of our change from before, but we're just getting that additional practice in to make it a little bit more comfortable when you're actually on your own trying to do this. It says 21.1, that answer is D. So your calculator is a very powerful tool when it comes to data analysis. We're going to work a lot with it this year, so please make sure that you're getting familiar with these things and their functions so that you are going to be able to get the most out of your calculator throughout the rest of the year.